Okay, lesson 3.5 on the back page. These are more the problems where you don't really see the logs in them to begin with for the most part. They are bases. They are exponential problems, okay? And so, like, as we look at A, 2 to the x equals 53. If 53 was a different number, we could talk about making these bases the same. But is 53 going to be 2 to some power? No. 53 is a prime number. It's not 2 to some power. So, with these problems, the bases will not match. To solve, you're going to want to take the log of both sides, basically, okay? We'll probably talk about isolating the power. You're going to want to take the log of both sides. With that in mind, you can do log any base you want. Typically, I tend to just do log base 10. You can do natural log. You're going to want to do one of those two, though, because we need to be able to hit calculator button, right? So, but this will allow us to pull the powers down with our power property of logarithms, and we can solve. And keep in mind, if you have a log, you can hit the log button on your calculator, and thus, as I said, we need calculators today. And then we will distribute, get the variables to the same side, factor. We're going to use the calculator to solve. So, as we look at A, when I taught this type of thing in Algebra 2, there was a section that's like, okay, can we make these bases the same? I don't even have that section today, folks. We're not getting these to be the same. So, since we can't, we have the power isolated, okay? So we want that first. The power is isolated. We're going to take the log of both sides. When I say take the log of both sides, basically I'm going to write this as log of 2 to the x equals log of 53. In this problem, I don't think it matters. If you would rather write natural log, you can use natural log. Okay. Keep in mind, our job is to solve for x. What can we do with x currently?
Put it out front.
Okay, our power property allows us to take an exponent and move it out front of the log as a coefficient. So that means I can write this as x log of 2 equals log of 53. Thoughts on solving for x?
Take the log of 2.
And what are we going to do with them? I personally am going to say putting them for decimal form till the very end. Just because they're big, long, messy decimals, and I don't want to have to write out those big, long, messy decimals.
Would you subtract over the log?
Not exactly.
To divide.
Divide over?
Oh,
because
it's being multiplied. Right?
Yeah. How are x and log 2 being held together? Officially, this is x times log 2, correct? And so if they are being multiplied, to undo multiplication, we're going to divide. So if I'm trying to get x by itself, I'm going to divide by the log of 2. If I divide the left by the log of 2, guess what? We're dividing the right by the log of 2. Log of 2's cancel. And guess what? You're off the calculator.
Answer.
Okay? I would, I know some of you would rather just let everyone else tell you the answers, but I would make sure you have a good way of plugging this into the calculator. I mean, it's not too hard to mess up, but there are ways to mess it up, so. I think I have 3 decimal places, so thousands. I tend to be one that likes to use a fraction bar.
Me too.
And so log of 53 divided by log of 2. Wouldn't have to use a fraction bar. If you do log of 53, you must end the parenthesis and then divide by log of 2. So whether you end the parentheses at the end of the log kind of depends on, they're not a necessity, depending on the situation. Or they are a necessity. Did we get it?
Yeah.
This is an easy one to enter into the calculator. Okay? But personally, the fraction bars are great. What is this if we go to the thousandths? 3 decimal places?
5, 7, 2, 8.
Okay. Today will not be the issue as much as of extraneous solutions. Just because, for the most part, these aren't logs that we're starting with, are they? Okay, so since they're not logs that we're starting with, it's not a, huge check issue because I'm going to assume 2 to this power is going to give me 53. I don't have to worry about, I can't do a negative power or something like that. Okay. B. Options for B.
No. Would it be log of 11.2 over log of 4?
Oh, you're right.
You gonna take me the shortcut right away? What's she using?
What we did last time.
Or if you don't, it's not log base 10 and you can't solve it.
Yeah.
Then you can.
Can you just use the change of base formula? Okay. If you catch it, yes, by all means. Okay. Change of base formula says, okay, I don't have a log base 4 button on my calculator, so I can rewrite this as log of 11.2 divided by log of 4, and I can plug that into my calculator, yes? Okay. What's your calculator give you?
12.7.3.
Okay. Now, I'll be honest, usually I don't get that answer the first time through. Or that I don't get that direction she took us. It's a good one. I like it. Is there technically another option we could have used? It's a little bit longer, but results in the same situation. To get it out of log form, could we take it to exponential form?
Oh, and then
You could. But here's the deal. You end up having to take the log of both sides anyways again. You end up having to go back to log form. So, something like a left-right middle here. Whoops. I mean, you could have done that if we do I'm not going to work this all the way out. If you would have done a left-right middle, it would have been 4 raised to the x equals 11.2. I often have students take me that direction. And then this is a lot like this one, isn't it? Where you would have to take the log of each side. And when you take the log of each side, guess what? You're going to pull that x out front, and then are you going to be dividing the same 2 logs we did up there? You are. Okay, so, it's an option either way. Katie did good. She took us the short way. But my point is, if you don't see the short way, you have other options. Okay? Okay, let's look at C. You only got so far on C? C gets a little more challenging. What can I say? You've had your break you in easy now. We've got to work at these. Can we make 6 and 8 be the same base? No, and there's not going to be a yes answer to that ever today. So what are we going to do? We're going to take the log of both sides. So log of 6 to the 3y equals log of 8 to the y minus 3. Okay, now what?
Put them on the outside.
Take 3y and write it up.
Okay, I'm assuming we're talking about moving these powers out front, yes? With that in mind, this first one, it's going to be 3y log of 6. So essentially that is 3 times y times log of 6. This next one, we're moving out front the y minus 3. Actually, because it's 2 terms being subtracted, I need to say y minus 3 in parentheses times log of 8.
Could you divide over the log minus 6 and divide over the y minus 3 so that things are, or your variables are
So your y's would all be together on the same side. However, by doing that, your y's are going to be in a fraction form.
Yeah.
And it's not going to be a pretty fraction. Okay, so agreed, we do need to get the y's all on the same side. Division is not the option, though, because that's going to make it ugly to work with. In order to get the y's on the same side, this is one term on the left, 3y log 6. On the right, this is y minus 3 times log 8. Keep in mind, log 8 is just some number. Okay, we don't know what number, it's some decimal or calculator can tell me. So if log 8 is just a number, that log 8 actually is going to get distributed to the y minus 3. Okay? So we're going to distribute this. So when I rewrite it out, 3y log 6 is staying on the left. On the right, I'm going to distribute log 8 times y. Now, I prefer to put the y in front in this case, so I'm going to say y times log 8. And then we're doing log 8 times a minus 3, so I'm going to say minus 3 times log 8. Okay. Now, can we get our y terms on the same side? How are we going to get our y terms on the same side?
Minus y log 8.
Okay. If I already have 3y log 6 on the left, I want to move y log 8 over to join it. How do you move a positive y log 8 over to join it? You're going to subtract it. So now I'm going to have 3y log of 6 minus y log of 8. And what's that going to equal on the right? Negative 3 times log of 8. Okay. We have all of our y's on the left, correct? However, can I subtract those terms? No. They have different logs. They're not like terms. I can't subtract a log 6 term minus a log 8 term. However, what I need you to notice is that both terms have a y in them, yes? So think GCF. Both terms have a GCF of y. Okay? So what we're going to do with those two terms, since we have all of our y terms on the left, is we're going to factor out a GCF of y. So I'm going to put a y out front. When I factor out y, so if it is 3 times y times log 6, you with me? It's 3 times y times log 6. If I divide out that y, what remains? 3 and 3 log 6. Minus. If this is y times log 8, and we divide out the y, what remains? Log of 8. Still equals negative 3 log of 8. I don't know if you see it or not, but one more step and we're there.
Would it be 6 cubed?
You could, but you don't have to.
Would you write it log or 3 log 6 over log 8 like divide them?
You could, but you don't have to.
Okay.
I'm not going to say you can't.
Would you add over the log 8? No. It's
No.
can you simplify the parentheses? Like, if you plug that into your calculator.
Well, what just happened? I'm not. Someone said it. Divide the whole thing. And here's the deal. Eventually, yes. Am I going to put 3 log 6 minus log 8 in my calculator? I am. I tend to hold on and do that, put it all in at the end, because I don't want to write all those decimals down, and and I don't have to want to worry about, oh, I need to carry some extra decimal places so my rounding is right. It's better just put it in at the end. So what I see is I see y times this expression in the parentheses. If we have y times something, how do you solve? You divide by something. So because that is all in one parentheses, we can divide by 3 log 6 minus log 8. If you divide the left by that, guess what? We're dividing the right by 3 log 6 minus log 8. Your answer is whatever you get when you plug that all into the calculator. So you're plugging that right there into the calculator. Negative 3 log 8 over 3 log 6 minus log 8. Could you have done some simplifying with the logs and stuff along the way? You could. But ultimately, we're going to be putting this in the calculator. So we don't have to worry about it. I would encourage you to try this one on the calculator. Make sure you get it right. I would also encourage a fraction bar. If you use a fraction bar, I feel like it is difficult to mess this up and get it wrong. Okay? If you don't want to use a fraction bar, you have to use parentheses around that whole section of what you're dividing by. So, negative 3 log 8 in parentheses divide by, and I'd have to do parentheses to start the problem. 3 log 6 in those parentheses minus log 8 in parentheses in parentheses. So it's doable without the fraction bar, but not the preference for me. What'd you give your answer as? Negative 1.893. Okay. Okay. I definitely want to do D. And here's what I will say about D. D has an E in it, and there are several. I feel like I should have picked some different examples for this page, but didn't think about that till this morning. It was kind of too late then. There are definitely some homework problems with E in them. Okay, so D is going to be a good example to look at here. E to the 2x equals 5 to the 3x minus 1. Well, silly question, but can I get those bases the same? No. And when we have a power on one side and a power on the other side, and we talk about the fact that we can't get the bases the same, what did we say we were going to do? Okay, we're going to say we're going to take the log of both sides. In this case, because there is an E, what is in your better benefit? To use natural log instead of regular log. Technically, you could use regular log and it would work out as well. But in your better benefit is natural log. Now, what I will say, before you take the natural log of both sides, and this relates to a couple of homework examples, always make sure you have that E term, so in this case, E to the 2x, isolated and by itself first. Okay, so isolate that E term first before you take the natural log of both sides. So that was a note I kind of wrote in on mine that I think will be helpful in homework. So isolate E term first. Okay. In this case, as we said, it's already isolated. So I'm going to take the natural log of both sides. Natural log of E to the 2x equals the natural log of 5 to the 3x minus 1. Okay. Thoughts on what to do next?
Put the exponents out front.
Okay, put the exponents out front. Now, and we can do that. There is a shortcut on the left. Natural log of e to the 2x. It's a good one to try and catch. Natural log is base what?
E.
Base e. Do you remember a property there?
So it's just 2x.
Natural log of e to 2x is just going to be equal to 2x. Because when those e's are the same, it's just equal to whatever your exponent is. My exponent in this case is 2x. Now, am I saying you couldn't do it the other way and bring that 2x out front? It'll work. It's very doable. Okay? It's kind of the longer way, but it's doable. Now, on the left, what are we doing with that 3x minus 1? We are indeed bringing that one out front. I'm going to put that in parentheses. 3x minus 1 times the natural log of 5. Okay. What's next? Yeah. Because we have x's on both sides, that 3x is in those parentheses. It's multiplied by natural log of 5. Take that natural log of 5 and distribute. So my left is going to stay 2x. My right, 3x times natural log of 5. 3x natural log of 5 minus 1 times natural log of 5. So I'm just going to say minus natural log of 5. My goal is to solve for x, so we're going to subtract the 3x natural log of 5 over. So I have 2x minus 3x natural log of 5 equals to negative natural log of 5. And? Okay. Both terms on the left have an x. They're not like terms, so I can't subtract them as is. So factor out GCF of x. 2x divided by x leaves me with 2 minus 3x ln 5 divided by x leaves me with 3 natural log of 5 equals negative natural log of 5. If it's x times that quantity in parentheses, you're going to divide. So I'm going to divide both sides by 2 minus 3 natural log of 5. And it's a calculator thing, right? Negative natural log of 5 divided by 2 minus 3 natural log of 5. What do we get?
I got positive 0.56.
And I was waiting for a response because my answer key has positive.
Did you put the negative on the top right?
It's negative natural log of 5 on top.
Oh, no, I didn't have it as negative natural log of 5.
Okay. So, I do have 0.569. And I have positive. Okay. I'm debating what I want to do here. But I technically could go ahead and give you work time.
Let's do F.
Yeah, can we do that?
We can. I'm not sure you're going to see anything exactly like F in homework.
Okay, then that's fine.
That's why I was kind of. Otherwise, I would definitely be like, oh yeah, we definitely.
No, we don't have to do it. That's fine.
But yeah, I feel like F. I didn't see anything exactly like F. I'm more thinking downfall of my notes. Okay, sometimes my notes sometimes have gaps in them, and I've realized, these type right here where there's E, you're going to see several with E. Okay, get that E term by itself before you take the log of both sides. Okay, that's going to be my suggestion. Now, and if you get motivated and want to try E and F, I mean, you can do that. I think E is a lot like C, so that's why I'm not as concerned about that one. Okay. Here, I'll write down. I have 7.3, whoops. 7.3059. And then I have 0.1175 on that one.